A very good morning to all the panels. I am Farah Salim. I'm from University Putra Malaysia, and I'm currently a final year student in Bachelor of Aerospace Engineering. So I'll be presenting to you my final year project, which is on investigating Tesla bed-less microturbine performance using computational fluid dynamics. Okay, brief introduction on the Tesla turbine. Okay, since the first aircraft ever flew used reciprocating internal combustion engine, an issue roses as saying that the reciprocating engines were dangerous and unpredictable due to the engine's lack of power. So this is what triggers Tesla to revamping the internal combustion engine to make flying safe for all and minimize its impact on the environment. So actually, the first patent, Nikola Tesla introduced his basic this design as a pump or compressor, which is now implemented in medical field uses for blood transfusion. Then only he modified his basic design into the second patent, which is turbine, and he claims that his turbine was able to achieve 90% of efficiency. Okay, next basic advantages of Tesla turbine. It's more efficient for low output application, and it offers like flexibility in its design, reduces vibration, can also handle corrosive materials or particles while maintaining its disk condition. Also, it is able to cater with the future demands of greener environment and sustainability using renewable energy. Okay, so which leads to my problem statements. Before that, a testing by Pashlakai and his colleagues in 2012 revealed that even the slight changes in the nozzle geometry can affect directly the power produced by the turbine, even though the rotor efficiency stayed relatively high. So recently, in 2018, Sengupta and Guha carried out a computational investigation regarding the nozzle effect by varying the number of nozzle inlet into 2, 4, and 8 inlets. However, from all those research, only for one type of design, the optimum efficiency obtained is only about 30 to 40%, which is far from Tesla's claims, which is 90%. Therefore, this project will be focusing on investigating the turbine efficiency in terms of nozzle design contribution. So my aim and objectives is to study the effect of nozzle design or inlet design in increasing turbine performance, and it can only be achieved by 3 objectives. First, to validate and verify the existing design using computational fluid dynamics with Sengupta's work. Second is to investigate the effect of or performance of different design in accordance to its rotational speed and power output. Third, to compare and optimize the inlet design in terms of turbine performance. Next, so a brief theory on Tesla turbine principles. It uses 4 basic principles: addition, cohesion, boundary layer, and also viscous force. So from the figure in the slides, addition is a sticky force from between the molecules and also the surface, and cohesion is a sticking forces between both molecules. Okay, so this interaction of addition and cohesion will build up a thin film, which is called boundary layer, and then a viscous force come in place, causes the molecules to resist separation, and then generates a pulling force, which then only rotate the disc. Okay, so next, my methodology. I'll be modeling the Tesla turbine, and then doing the CFD analysis using fluid and I'll be doing the validation, both quantitative and qualitative. Also, if it's good, the result is good, I'll be continuing with my research work on inlet design, and I have 2 inlet design as on our right, and top figure, it shows the circumferential design, and the below is actually the theory of pitot tube, which it captures the gap between each case. Okay, so for the pitot tube, I'll be doing 1 opening, 1 inlet, 4 openings, 1 inlet, and also 4 openings and 4 inlet. Okay, next. So my boundary condition will be steady flow, laminar, incompressible flow, and I'll be having mass inlet flow with a flow rate of 30 exponential minus 5 kilogram per second, and it's introduced perpendicular to the boundary. So a pressure outlet with a static pressure setting, and also reversible flow is eliminated from re-entering the outlet. My casing is a stationary wall with no slip shear condition, and my domain is a moving wall with a rotational speed of 800 radian per second. Okay, next, this is my briefly about my circumferential or the validated design, casing, inlet and outlet. And for the disc cap, I'll be having a thickness of 0.3 millimeter, and the radial clearance between the casing and also the disc edge is about 0.2 millimeter. Okay, so optimization of my inlet design is, this is the 2 basic inlet design. Okay, so we'll be extending the inlet as the 2 figures below, extending the inlet by 5 millimeter to ensure laminar flow. Okay, so my result in discussion. Okay, for the rotational speed, I'll be choosing 800 radian per second since it has the nicest line curve. Okay, the red one. Okay, so I'll be using the 800 radian per second throughout my investigation analysis. So comparison between different inlet design, as I told you before, the effect of an extended inlet is to ensure a uniform flow, and also to ensure that enough energy is obtained in order to rotate the domain. Okay, and it is found that the maximum velocity of the extended version is actually twofold than the basic design of Sengupta's work. Okay, so it is proven that extending the inlet increases the torque and also the power. Okay, next, the effect of pitot tube, different number of openings for one on inlet only. I'll be comparing different number of inlets, different number of openings, 1 opening and 4 opening in 1 inlet only. So from the graph, from the table, there is a significant increase of about 31.12% in both torque and power, and this is considered high for a micro Tesla turbine. Therefore, it is proven that by having more openings help produce more power and torque. Okay, so next, I'll be comparing the same different of openings in 4 inlet, which is the optimum inlet for Tesla turbine. And it is seen that it has a significant increase, and it's about 100-fold. Sorry for the typo there. It's not 1,000-fold, it's 100-fold. And it's again proven that 4 openings is better than 1 opening. So my conclusion is just, as I mentioned before, it's extended length of extended inlet is really helpful, and also for pitot with 4 inlets and 4 opening is proven to be effective in producing more torque at low pressure. Okay, and therefore that is all. Thank you.